So you imagine you have this hourglass figure type thing. If I take a saw and run it through and I cut it flat like this, okay, I'm just going to cut it flat. But when I lift that off, it's going to look just like the top was. And as long as this is circular, which it's supposed to be, when this saw cuts it through, if I were to make a stamp out of this, this would also be a circle. Okay, so I can cut this conic section by cutting it straight across and I get a circle. Now I want you to imagine that I just cut one of these cones and I cut it straight down. Okay, what I'm going to get is I'm going to get a parabola that comes here and then one on the back side that you can't see. So there's the shape that I make when I cut it straight down, and it's actually a parabola. You know, if I were to take this chunk that I cut off and look at it and be like, hey, look, well, this would make a parabola. Okay, now if I cut it all the way through on both of these, so I cut it all the way through on both of these, so it's going to come up here and come here, and then it's going to come over onto this side and come there. I now have two parabolas. They call that a hyperbola. Okay, so that's a hyperbola. The other one that we could get is if I cut it diagonally, like this. Nope, that's straight. Diagonally. Well, this would, if I were to look at my shape when I'm done, it actually makes an ellipse. Okay, so it makes an ellipse when I cut that off. So those are my four shapes that I could look at. I can either see a circle that we're going to look at. There's probably other things, but this is all that we're going to talk about. A circle, an ellipse, hyperbola, and parabola. Okay. On page 682 and 683, it has some great, just pretty much straight out notes for you. Okay, but here's the general form for a circle: x minus h squared plus y minus k squared equals the radius squared, where h and k on all three of these, hk is the center. Okay, on the parabola, hk is the vertex. So, whoops. So that's on those. Now, the equation of ellipse, the difference between an ellipse and a circle is that these have different numbers. Like on a circle, these are the same numbers, so whatever this radius is. On an ellipse, it equals 1. And then we have a squared and we have b squared. A hyperbola has two different equations. One because it, no. I was going to say one because it does. No, really the answer is I could turn my hourglass on its side and I would have these hyperbolas like this, or they could be running up and down like this. Okay, so on an ellipse, somebody told me it's kind of like where the red fern grows. You know, he has little Ann plus Dan because they're in love and they go towards each other. Well, that's kind of like ellipse. It's like two parabolas, and their hands come and they hold hands and they're all in love. I don't know. Anyways, the other one, these were like, these guys hate each other. They run away from each other. They're opposites, whatever you want to think. Well, this formula looks like this. X minus h squared over a squared minus y plus k squared over b squared equals 1. Okay, so that's the biggest difference between a hyperbola and ellipse is the minus. Okay, and then the other one, so this is a hyperbola that opens sideways. The one that opens up and down is this one. So y minus k squared over a squared minus x minus h squared over b squared. So when the x is negative, it's kind of like we get rid of the x-axis and it just deals with the y. When the y is negative, it's like we don't like the negative thing, so we get rid of the y-axis and it goes over the x. However you want to remember that. Parabola, it also has two for the same reason. One's over the x-axis and one's over the y-axis. So let's do the one up and down first. So x minus h squared equals 4p y minus k. So this is the one that goes up and down. Okay, if it's a negative, then it goes down. And this one, y minus k squared equals 4p x minus h. So this is the one that goes side to side. Okay, so those are the four different things that we look at: parabolas, hyperbolas, ellipses, circles. These are the general equations. I'll show you how to graph those in a moment. But this is kind of the introductory formula type things that we have and how to tell the difference. So come on, page. Move to the next one. On a circle, we could write these so they're not in that nice, pretty standard form. Instead, they're like this. Okay, they have everything on one side. So a circle, notice how both number in front of the x squared and the y squared is the same, like that coefficient is going to be the same. On an ellipse, it's a plus, but those numbers are different in front of the x squared and the y squared. On a hyperbola, that's this one, these numbers are different, and it's a minus between them. Okay, so on a hyperbola, the numbers are minus between them. On a parabola, only one of them is squared. So you're either going to have ax squared plus bx plus cy, or you're going to have ay squared plus bx plus cy, something like that. Okay, but only one of them will be squared. You won't have two different ones that are squared. So again, hk is the center. Now, this a squared and b squared stuff, once we find where the center is, this tells me how far left and how far right to go to get to the vertex. Okay, so that's how far left and right to go to get to the vertex. So this tells me to go, if it's below my x's, that tells me to go left and right on your x's. If it's below your y's, that's how far we go in our y direction. Okay. There's one last thing that we need to talk about with ellipses and hyperbolas. I'll get to this parabola in just a second. On an ellipse, so this is what an ellipse looks like. Okay, here's the center. Well, there are two different little things like this, or if I have an ellipse like this, these two dots are the foci, or focus. Each one individually is called focus. And to find the distance from the center to the focus is C. Okay? We call it C. I don't know why, but it's C. And it's a Pythagorean theorem type thing. But because it's inside, instead of being a plus, it's a minus. Okay? Now on a hyperbola, so I have a hyperbola that looks like this. Well, inside those parabolas is the focus. Now, because it's from the center further than the vertex, it's the plus. Okay, so I'm going to do a bunch of example problems showing you all these and talk about it. Now, on a parabola, this is the general equation of the parabola. This p is the distance from the vertex to the focus. So there's a little focus right here, or a little focus right here. Well, the distance from here to here is p. Okay, so that's the length of that. And it's just, we just say whatever this number is. If that were like 12, I'd say 4p equals 12. Divide it by 4, and p equals 3. Okay, and then there's one more thing. Suppose I have a parabola that looks like this. Here's my focus. This line always has a length. So from here to here, so the end points of this line lie on the parabola. This length is always whatever this number is. So like if it were 12, this would be 6, and that would be 6, and that would be a total of 12. Okay, so this 12 tells me how far it is through the focus from one endpoint to the next endpoint of a line which connects the parabola. Okay, so here's my line, has an endpoint here and an endpoint here. That endpoint is on the parabola. It's a length of this number. So if I split it in half, that tells me how far to go above and below that point. Okay. So anyways, that's an introduction to this. Like I said, page 682 and 683 have great notes on it. So that's the introduction to the note part. And then I'll do some examples for you in the next section.